Okay, the last part of chapter 5, we get to talk about our last special right triangle, and that is the 30, 60, 90 triangle. And the 30, 60, 90 triangle is very special, just like the 45, 45, 90 triangle, because we have some shortcuts that always happen. So if you think about a 30, 60, 90 triangle, this side's 30, we'll say this is 60, and here's our 90. If you think about adding on another 30, 60, 90 triangle, what kind of triangle does that make? Oh my gosh, it makes an equilateral triangle. So that means, let's say if this side was 10, then this side would be 10, and this whole side would be 10. So that means that this part would be 5. And we could do Pythagorean theorem to find out how long this side is. And we'll call this side the longer leg. We could call it B if you want to. And we're going to call this the shorter leg. And the reason why this is shorter is because, or A, because it's across from the 30 degrees. So this has to be shorter. This one's across from the 60 degrees, so this has to be longer, even though my picture doesn't really look like it. Okay, so we could do Pythagorean theorem. We'll say 5 squared plus b squared equals 10 squared. Same thing as a squared plus b squared equals c squared. Okay, so we've got 25 plus b squared equals 100. We're going to have to subtract, and we get b squared equals 75, and then we square root, and we get b equals radical 75, and then we're not done. We have to simplify. So 75 is the same thing as 3 times 25, and then 25 is 5 times 5. So we've got our pairs that go out together, and then we have this loner. And that's our answer, 5 radical 3. So I want you to notice something. There's a pattern here that goes on. What are some similarities between the short leg and the hypotenuse? Well, if you take the short leg and multiply it by 2, it's going to equal the hypotenuse all the time because it's half of an equilateral triangle. Another shortcut, there's 2 shortcuts for this one. Another shortcut is that the longer leg also has a 5 in it, right? It's just a 5 times a radical 3. So the longer leg is the shorter leg times radical 3. So if we know what the short leg is of a 30, 60, 90 triangle, we can figure out what the hypotenuse is and figure out what the long leg is without having to do Pythagorean theorem. Now, it's not that difficult. You can still do Pythagorean theorem. But you do need to know, you do need to at least know, oops, this is 45, 45, 90. You do need to at least know that the hypotenuse is always going to be double of the shorter leg. And notice the shorter leg is always across from the 30, and the longer leg is always across from the 60 degrees. That's super important. Okay, so let me give you some examples. Let's say, for example, I give you the hypotenuse. So I know that the hypotenuse equals 22, and I know that one shortcut is that the hypotenuse is the short leg times 2, right? So if the hypotenuse is 22, that means that the short leg has to be what? Well, it has to be 11. You need to at least understand this part. If the hypotenuse is 22, this part has to be 11 because this is just half of an equilateral triangle, and so this part would be 22, this part would be 11, and this part would be 11, making this side 22. Okay, so if you just remember that this is just half of an equilateral triangle, you'll be golden on getting the shorter leg. So shorter leg, check. From here, once you get here, you can use Pythagorean theorem. You could say 11 squared plus y squared equals 22 squared and figure out what the longer leg is. If you want to use the shortcut, remember the longer leg equals the short leg times radical 3. So once you know that it's 11, all it is 11 radical 3. And you're done. And if you don't believe me, that's totally fine. We could do Pythagorean theorem and figure it out. So 121 plus y squared equals whatever 22 squared is, 44. And then you're going to have to subtract, and we get 363. And then we're going to have to do the factor tree. And let's see, I'm going to say that 363 can be split into 11 and 33. And then 33 can be split into 11 and 3. And here's a pair. They go out together. And here's the loner. Now, 11 radical 3, 11 radical 3. This is just more work, but you can still get the correct answer using Pythagorean theorem. So something I want you to notice is that with the 45, 45, 90 triangle we talked about yesterday, that one always had a radical 2 in it. For the most part, there's a radical 2 somewhere in there. And how I remember that is, well, there are two 45-degree angles, so there should be a 2 underneath the radical. For 30, 60, 90 triangles, there should always be a radical 3 somewhere in your answer. And how I remember that is, well, there's a 3 in 30, so there should be a 3 in your radical. For the most part, for the most part. Okay, so let's try another example, and I want you to see if you can do this one. So pause it and try it yourself. Okay, so there's a radical 3, which sometimes people are like, what? That's scary. Same thing, same thing. You've got to know that the shorter leg, which is x, times 2 will equal the hypotenuse. The hypotenuse is always double the shorter leg. So if we know that it's 18 radical 3, all you have to do is divide it by 2, and that'll equal the shorter leg, right? All you have to do is divide by 2, and you'll get the short leg by itself. So you can't combine whole numbers and radicals, but if you look at the whole numbers, well, that's just 9 radical 3. So the short leg x equals 9 radical 3. Okay, that's one part. Second part, to find the long leg. You know that the long leg is the short leg times radical 3. Now, we already know that the short leg is 9 radical 3, so all you have to do is multiply it by radical 3. Radical 3 times radical 3, remember, that gets rid of the radical, and you're just left with 1 3. And then 9 times 3 is going to be 27. And if you're not sure, because some people may be like, wait, hold up, just a second. 27, that looks a lot longer than 18 radical 3. And 18 radical 3 should be the largest side because it's the hypotenuse. It's across from 90 degrees. Pop it into your calculator. 18 radical 3 is larger than 27. And it's larger than 9 radical 3, obviously. So that's one way to check your work. Another way to check your work, you could do Pythagorean's theorem. 9 radical 3 squared plus y squared equals 18 radical 3 squared. And notice I'm putting parentheses even though you can't see this one. So you put parentheses because you have to square both things. So 9 squared, that's 81. Radical 3 squared, that's 3. So 81 times 3 is going to be what 9 radical 3 is. So that's 243. And then 18 radical 3, you do the same thing. You'd square the 18, and that's 324, and then you'd square the 3, and that would be 3. And then if you combine those two things, that would be what y equals, and then you just solve like normal. So then that's one type of question. Another type of question that's harder, probably the hardest question, is what happens if I give you the length of the leg. If I give you the length of the leg, we can still use the shortcuts. So I'll show you the shortcuts. The shortcuts are that the longer leg equals the short leg times radical 3, and then the other one is the hypotenuse equals 2 times the short leg. Those are our shortcuts. So since this is the only one that talks about the longer leg, you have to use this one first. So we know 15 equals the short leg, which is 30, which is x, times radical 3. And then to get x by itself, you have to divide by radical 3. And then you have to go through all the steps because we do not want a radical on the bottom. So what you'd have to do is multiply the top and the bottom by radical 3. And that gets rid of the radical on the bottom. And you're left with 15 radical 3 on the top. And then you look at the whole numbers, reduce them, and you get that the shorter leg is 5 radical 3. So x equals 5 radical 3. And then to do the hypotenuse, all you have to do is double whatever the short leg is. So 5 radical 3 times 2 is going to be 10 radical 3. Now if you wanted to do Pythagorean's theorem, you would say that since this is x, this is going to be double x. So the hypotenuse is really going to be x squared. If you really, or I'm sorry, 2x. I don't know why I said x squared, excuse me. So if this is x, you just double it to get the hypotenuse. So if you wanted to use Pythagorean's theorem, it'd be x squared plus 15 squared equals 2x squared. And remember the parentheses because you have to square both of those things. Okay, so try, I know that's the hardest type of question I could give you. So try this question. No, that's an easy one. Try this question and see how you do. And I will give you the answer in the next video.